My name is Darren Bax. I'm the director of the Center for Energy and Environment here at the Competitive Enterprise Institute. There should certainly be free and open discourse on issues. We certainly expect that when it comes to science, but there's a major crisis going on in science. We're all too often challenging conventional wisdom is a sure way to not get published, not get a job, or worse. And that's especially true when it comes to climate science. And that's why this morning we're pleased to hear a different perspective on climate science. But even better, we have the opportunity, the rare opportunity, to hear from a Nobel laureate in physics. I want to thank the CO2 Coalition for making this event possible and working with us here at CEI to host our featured speaker, who'll discuss the Intergovernmental Panel on Climate Change, which is the IPCC. He's going to talk about their thoughts, their findings about warming, then also discuss what he's found regarding warming and specifically the effects of cloud cover on the climate. So I'm going to move quickly. I'm honored to introduce Dr. John F. Clauser, an American experimental and theoretical physicist who was a 2022 recipient of the Nobel laureate in physics for pioneering work in quantum mechanics. Dr. Clauser.
Okay. So in addition to being a Nobel laureate, I have come out of the closet and I am now officially a climate change denier. Oops, how do we get rid of? Okay. The IPCC was tasked with measuring and computer modeling two very important numbers. The Earth's so-called power imbalance and its power imbalance feedback stability. Based on their observational data and their computer modeling, with great confidence, they say, there's more power coming into the Earth than is re-radiating back out as heat. And so, therefore, the Earth is warming. In their 2021 sixth assessment report, they say it's 0.7 plus or minus 0.2 watts per square meter power is coming in more than going out. Plus or minus 0.2 watts per square feet. Incredible precision, they promise. Moreover, they say that this is caused by the accumulation in our atmosphere of CO2 and methane, the greenhouse gases, which they have defined as pollutants. Once you define it as a pollutant, it then fits under the Environmental Quality Act. So that takes the out of the Department of Energy's hands and puts it into the EPA's hands, the control. And they, of course, exclude the most important greenhouse gas of all, over which they have no control, water. Okay, they assert that this accumulation is going to lead to an apocalyptic climate change. Extreme weather events will consume us. Moreover, their collaborator, NOAA, the National Oceanographic and Atmospheric Association, asserts that that's already happening. And they show data which disprove their own claims, actually. And they also, the second number had to do with feedback mechanisms that they were asked. And they show that, well, they're really pretty marginal, and there's going to be a tipping point if we get too much CO2 in the atmosphere, and we'll get a thermal runaway of the atmosphere. And so they're saying, well, the world needs to spend trillions of dollars for a zero carbon policy, And even worse, trillions of dollars per year just on geoengineering projects to reduce CO2. Okay, what is this infamous power imbalance that I'm talking about? It's the difference between the amount of power that's coming in to the power that's going back out. So if there's more power in than power out, we're slowly heating the planet. Okay, and this is measured at the top of the atmosphere. And this imbalance is, in fact, their definition of global warming. If there's more power in than power out. Okay, what is the power in? Sunlight. The sunlight is warming the Earth. Okay, it's about 340 watts per square meter of surface area. What's the power going out? Well, it's a lot of that sunlight just gets immediately reflected. So like a sheet of white paper reflects 99% of the light that hits it. Okay, they claim that's about 100 watts per square meter. There are actually two components. The second component is far infrared heat, what you feel from a radiator that's coming out. That's 240, so the sum to roughly 340 watts. I assert that they screwed up and totally flunked determination of those two numbers. Their determination is badly wrong. The computer modeling that they've done, that was done mostly at Goddard Institute for Space Studies, which I'm now embarrassed to admit is where I wrote my PhD thesis. This was pointed out earlier by Steve Koonin in his book Undecided. It's a Wall Street Journal bestseller. That there are 40 different models that they've used, and they're all in total disagreement with each other. Okay, so much for the theory. They also, what I will show here is that not only is the theory bad, the observational data are also bad. Okay, they claim that there's actually that this summation, there's a very narrow range, it's 0.7 watts per square meter. That's only about 0.2% of the difference between power in and power out. Unfortunately, when you look at the actual data, the data are very clumsily fudged, right on the very pictures that they try to show. They are just simply scientifically dishonest. The actuality is that all the various modes of measuring this are all in violent disagreement with each other. And among the investigators who are running disagreements, typically they had to fudge one of them by one group by 10 watts per square meter just to try to get it to agree with the other one. And the investigators themselves point out, it's really impossible to measure this. Okay, so my contribution to all of this is what I believe is actually really happening. This reason, one of the reasons it is so hard to measure this is that this power imbalance is wildly fluctuating. And the fluctuations are like 18 to 55 watts per square meter fluctuation continuously. That fact alone is making it very hard to measure. But that's actually, I would claim, is not totally random. One would think, gee, weather is kind of a random stuff. No, it's not quite. That it's actually a feedback mechanism that is actually controlling and stabilizing the Earth's temperature and climate. That it's just like the thermostat in your home. It keeps the average power imbalance to 0. Okay, so the second number they were asked to measure was the feedback strength. They claim it's minus 1.16 watts per meter squared per degree Kelvin change. That's how strong this feedback mechanism is. Okay, the cloud mechanism that I'm going to talk about is anywhere between 6 and 13 watts per square meter in strength. So I argue both of the important numbers that they were asked to measure are dead wrong. And so one of the things that the IPCC is asked for is to produce what they call solar radiation management systems, or first one already there. It's the world's cloud cover. It works. So I assert that there is no climate crisis, and the IPCC's claims are false. And worse yet, we are needlessly spending trillions of dollars. Okay. So I'll go on and show you slides where how badly their computer modeling is. This was pointed out by Steve Koonin. So much for theory. The experiments. I'm going to talk about how the various modalities for measuring this were all in violent disagreement with each other. Moreover, the investigators who are doing this say, this isn't going to work at all. It's virtually impossible to do it with satellites or buoy data. Nonetheless, whoever was running the show said, here's the numbers. We're going to stick with this. Okay, so there's the methods where there are satellites measurements. There's the Terra, the Aribe and the Ceres satellites, the Terra and Aqua satellites. There's the ocean heat content measurement system that was championed by Jim Hansen. And there's also the baseline surface, where they just put out a whole series of measurements of sunlight all over the world. All of these measurements are in wild disagreement with each other, and the reports are totally fudged. And finally, if I have time, I'll show you how NOAA claims that the climate extreme weather events is totally wrong. Okay, so what I'm replacing this with is what I call the cloud thermostat mechanism. It provides very powerful feedback, just like your house thermostat. Okay, and I will point out some very underappreciated properties of clouds. Okay. The feedback strength is like anywhere between 45 times the strength of any of the feedback methods, or up to almost 770 times the strength. When it is by far the most powerful feedback method, and they totally missed this. Okay. Move on. Okay, so this was a picture, a graph from the IPCC's fifth assessment report in 2013. This was actually published, I think, after Steve Koonin submitted his book. But okay, these are the so-called predicted and historical temperature anomaly. They use strange ways of it. These gray curves here, you can barely see. Okay, the black curve is the actual temperature, which shows that this goes up to 2013. Shows that the temperature was actually leveling off versus time. They were trying to simulate the history. They can't even do that. There's huge fluctuation. So they just let the simulation run, and here's what they predict for the future. The somewhere they say, well, here's going to be our tipping point. We got it dangerous. And this only goes to 2050. They're worrying about the tipping point in 2100. Okay. Before I go further, there's a word that everybody uses that sounds kind of mysterious. It's called albedo. It's a fancy word. Remember, we've got 100 watts being reflected. It's a simple dimensionless number that shows what is the total reflected power strength. It's the fraction of the sunlight that hits the earth that gets reflected. So we have 100 watts reflected, 340 watts per square meter in, and so the albedo is 0.3. Okay, this part Steve Kuna didn't get to, but finally Stevens et al. In 2015 published measurements of the albedo. Remember, they're saying that we're looking at that they've measured this precisely to 1/10 of a watt per square meter. Okay, and he goes out, wow, the actual total reflected light is fluctuating by the order of 10 watts. Now, and that's okay. The black curve here is the actual average of 10 years worth of data. These various yellow and green curves and red curves here are what Goddard Institute of Space Studies tried to simulate. They can't even get within 10 watts of their simulation of how much reflected sunlight there is. They can't even get the phase of the oscillation right. And this is actually a very small fraction of it because sunlight power is actually oscillating just because of the eccentricity of the Earth's orbit around the sun. Sunlight power actually is varying by about 5 watts per square meter. So the total fluctuation is the order of 16 watts per square meter. So suppose you're an experimentalist and you're asked to measure this stuff. Remember, this is the sacred quest that the IPCC has been tasked with. It is getting it right is worth trillions of dollars. And you're asked to get it right to within 1/10 of a watt per square meter. I'll show you this. In fact, none of the observations actually show a net warming energy imbalance. And the investigators themselves admit that it's impossible to actually measure this small an imbalance that's fluctuating. So nonetheless, whoever finally published the papers just simply fudged the data to show that claim that it's warming. Okay, so what's a simple calculation consist of? Here we have 340 watts coming in. We have 100 watts coming out of reflected sunlight. We have 240 watts of heat being re-radiated. So you calculate, do the sum, and if it's in perfect balance, it should be 0. Okay, put error bars on this. The standard way of calculating the way we do in the physics business is to take the root mean square of the various error bars. So any one of these error bars has to be smaller than the final error bar. And you get an imbalance. So if it's greater than the imbalance is greater than the error bar, then we have warming. If it's not, we don't. Okay, so the earliest data were by Stevens et al. In 2018. These were from the Aribi satellite. And it was up there for years. They only had a chance to analyze 4 months, and they didn't even get those 4 months worth of data carefully analyzed. it's not a simple sinusoidal variation, so you need more than 4 months to catch the time variation. But so in 1981, Stevens et al. Came up with, he says it's 9 plus or minus 10. If I do that sum, I get 6.8. Ramanathan in 87 did the same thing. He said 0. He wasn't specific on where he puts his decimal point. They're both fully consistent with 0. No heating, no warming. The National Academy, in their 2003 report, said the observations do not meet quality standards. Okay, so Loeb et al., 2009, 2012. This is mostly at the urging of Jim Hansen. Jim Hansen said, well, what you really look at is the warming of the oceans. We've noticed that a few places the ocean temperature is changing. Actually, most of that change is due to all these huge El Nino oscillations of the fluctuations of the currents, of warm ocean currents, but they didn't know that at the time. But nonetheless, Jim Hansen insisted that we do this. So they insisted then they Loeb et al. Said, well, okay, everybody can see it's impossible to make this measurement with satellites. So we're going to do it with the ocean buoy data and just water sampling by ships throwing thermometers overboard. Okay, and this was all mostly due to the program set up by Jim Hansen. So here's what they came up with. Okay, so here's the satellite. They just said, well, we're going to rewrite the satellite numbers. Here's the ocean heat content. And they say, well, that's slightly warming. And then finally in 2012, they throw out about 10 numbers in the article. And they say it's 0.64 plus or minus 0.011 watts. Remember, we got a fluctuation in the order of 10, and they're claiming they're getting it to 1/10 of a watt, because that's what was demanded of them. Okay, and where do they get the data? Well, these buoys are just sort of sparse all over the place. They made it up. Lyman and Johnson just simply fabricated the data. In science, that's one of our little no-nos. Okay, so Stevens et al. Did the original satellite work. And Loeb et al., they kind of merged the groups, and they agreed, well, satellites aren't going to do it, so we're all going to switch to ocean heat content. And so here's our simple summation. Here's power coming in, 340 plus or minus 0.1. Remember, it's fluctuating by the order of 5 watts, just the sunlight itself. So they ignore all that. Okay, so here's 100 watts going out of reflected sunlight, 239.7. They say, oh, well, it's got to be this 0.6 plus or minus 0.4 now. Remember, it was 0.01 earlier. Okay, remember this number. It's going to show up again because they keep dragging it out. Okay, when I do this sum, I come out with 0.5 plus or minus 3.9. Nowhere near claiming there's warming. But nonetheless, here's what they publish. You don't believe me? Just get their article. Here are their 2 graphs they show. Here's the 340 watts coming in. Here's their power flow map. Here's the 340 watts coming in. Here's the 100 watts going out. It's the reflected light here. Here's the heat going out, 239. Here they do the sum, 0.6 plus or minus 0.4. Anybody, all you do is just get these articles and just simply add up the numbers, and they don't work. And it was really clumsy that it's so obvious. LeCoyer, who was in the group with Stevens, reanalyzed this. He was a little embarrassed, I guess, to be part of the group. So he puts a kind of a minority report out, 2015. So he revises and he says, well, okay, the ocean heat content really sum up as 340, 102, 0. Well, we got to put in some constraints as to how we fudge the numbers. Again, still adds 0. Well, okay, here's his power flow diagram. Here's the 238 going out, the 340 coming in, the 102 reflected sunlight. Okay, so Trenberth and Fastulo were kind of the original whistleblowers on all of this. And they pointed out, well, okay, you're really doing an apples and to oranges comparison here. The top of the atmosphere is where we're going to do this imbalance calculation. But the ocean heat content is measured at the surface of the Earth. In order to mix up numbers at the top of the atmosphere and numbers at the surface of the Earth, you got to know what's going on in between. You got to fully understand it. And they argue that you don't. So they're very critical of this whole program by Hansen, Loeb, Stevens, and LeCoyer, who are analyzing the ocean heat content data. And they point out, these things the satellite data are very different from the ocean heat content data. And they asked the simple question in an article in Science, where does all this power go? This huge difference. Hansen comes and returns in an article, and he just simply dismisses it as all unimportant. He says, well, satellite calibration errors are off. But nonetheless, the final review they do says, no, we've done it carefully, and there are still big discrepancies. So now, remember Stevens and LeCoyer, they were kind of at opposite ends, even though they wrote the first paper. So they finally get together and publish a paper in 2015, which is actually a mea culpa, literally, where they point out, there was a choice that we made, then there was adjustments, I call them fudges, and we made those adjustments in a totally ad hoc fashion. I am quoting directly words from their paper. And there is no real evidence to support one adjustment over the other. So they say, well, both numbers were right, but in the abstract, it's still 0.6 plus or minus 0.4. Where did that good number go? Okay, here's what they show. If you add up it's plus or minus 5.6. Satellite data, plus or minus 5.6. Nonetheless, it says 0.6 plus or minus 0.4. Okay, so then finally time goes along, and Wild et al., or maybe it's Vild, I'm not sure how you pronounce it, publishes 2015 and 2019 new report. This one he gets from looking at the sunlight data on various sampling stations all over the world, and looking up at the sky with pyroheliometers and measuring the total input sunlight flux. Okay, and they publish following set of numbers: 340 plus or minus 0.5, minus 98, minus 239. Hey, Meso, they get 0.6 plus or minus 0.4. Where'd that number come from? I do this sum, I get 3.5 plus or minus 3.6. Okay? So finally then, the IPCC's 6th assessment report comes out. They virtually copy this power flow diagram from Vild et al. And they readjust the numbers, and they say, well, actually 0.6 isn't enough. 0.7 is how much we're warming, and they dropped the error bars by a factor of 2. Actually, they dropped them by a factor of 4, because this was a 1 sigma error, and this is, they claim, is a 2 sigma error. If you don't believe that, here they are. Here is Weld et al.'s power flow diagrams. You just get the article itself. Here's your 340 coming in, 100 going out, 239 going out in the summation. Here they put on the bottom is their 0.6, but they got it going down here. But here, so IPCC in their 6th assessment report, 2021, 340 coming in, 100 going out, 239 going out, 0.6 plus or minus, or 0.7 plus or minus 0.2. And it's right there in the face. Anybody can just do the addition himself or herself. Okay, so what's going wrong here? Here's what they're ignoring. What do you see when you look at the Earth? Here's some pictures of it. If you're looking at it in sunlight, this is a famous picture taken by the original astronauts. Not much clouds. Here you have here's a picture of Africa, Australia, lots of clouds. Here's the Pacific Ocean, mostly cloudy. Okay, 5 important things you need to remember from those pictures. Clouds are white. They reflect a lot of sunlight. Okay, the photos show the typical reflectivity is the order of at least 0.8 to 0.9. For comparison, a white sheet of paper is 0.99. So it's okay, whereas if you look at the land or the ocean, it's more like 0.16. The second thing you need to remember is that they vary a lot. Remember, we had one picture where the Earth is nearly cloudless. Another is totally cloud covered. Second thing you need to remember is that clouds cast dark shadows. It was very obvious. I was flying into DC yesterday afternoon. The airport, there were a whole bunch of random clouds, and you could see below them very dark shadows all over the ground. Okay? Just stand on the hillside and watch clouds go over. You can see dark shadows. If you have solar heating in your house, look at the ammeter, the amount of power that's coming in when just a simple solitary cloud passes over. I noticed this when I was sailing to Hawaii at one point. Typically, at least you only get typically less than half the power is coming out. Okay, in your home or apartment, on an overcast day indoors, try reading a book when it's dark outside. You can't because it's too dark. Where did all of that sunlight go? It got reflected back out into space. This 100 watts going out is probably wrong. Second important thing to notice, if you remember that diagram from AR6 or Weld et al. What does sunlight do when it hits the Earth? Most people say, well, it warms the Earth. That's true over land. Land is only 30% of the Earth. 70% is the world's great factory, like the oceans. 70% of the Earth's surface is covered with oceans. That's where all of the exposed water surface is. Okay, so we have, if you look at their diagram, they have 160 watts absorbed by the whole Earth. So 70% of that is, say, 112 watts absorbed by the oceans. Okay, they show that there's 82 watts is used not for warming the Earth, but for just simply evaporating seawater. What does that seawater do? It makes clouds. So what is that? So 82 over 112, that's 73%, or 3/4 of the sunlight power is used to make clouds, not to heat the Earth. Okay, so the satellite guys had not gone to sleep, even though everybody dismissed satellite data as being unimportant in 2012. So King et al. Analyzed 13 years worth of the Terra and Aqua satellites. Very beautiful experiments, actually. They did a very good job. And they published what fraction of the Earth is covered with clouds. And they separated out very nicely, the first time anybody had ever done this, the oceans and the land when the satellites were over. Here are the fluctuations of the cloud cover. Okay, this is like 13 years worth of data versus time. The black line and the dotted line, the same satellite, 3 hours apart. Actually, there were two satellites, the Terra and Aqua, going around the same orbit. Okay, it's a huge change here. So I added, well, how much reflected light are we talking about? Here's what you get over land, is the red curves down here. So it's a huge change. So here's what a cloud experiences when it goes from ocean to land. It's the order of 18 watts. Well, how did I draw this scale here? Okay, I assume we got like 340 watts coming in. And I use the numbers and the albedos. Now, it turns out you could calculate, there's an energy conservation that nobody seems to pay much attention to. That, well, the total coming from the clouds, the total coming from the non-clouds has got to sum to the total. When you do that, okay, they show what the cloud, those two diagrams I showed were the IPCC and Wild, each one showed one was cloud-free sky and one was the whole Earth. Well, there's the missing one, which is the cloudy sky. Okay, well, you look at that. They put in those numbers, you get a reflectivity of clouds of 0.36. That's not what we saw in the pictures. The pictures are more like 0.8. It's bright white clouds. Remember, that was one of your take-home messages. Okay, so if you put in instead 0.8, then you get a 55 watt random fluctuation. It's a huge fluctuation sunlight, and that doesn't even include the additional 5 watts due to the change in the solar constant due to the varying sunlight due to the Earth's orbital ellipticity. So, now, if you remember with that very first picture I showed you, 2015 by Stevens, where he showed the fluctuating albedo. He did not break out land and ocean on that, but he was showing the order of 10 watts per square meter. So if you actually look at the difference here, it's much bigger. Okay, so how does this cloud thermostat mechanism that I'm talking about work? Okay. Most of the ways, when you remember, most of the power coming in is evaporating water. That's all it's doing. It's making clouds. Okay? And the thermostat works just the same way that the one in your house does. It controls the temperature in an on-off fashion. The power imbalance is never zero. It's either your heater is always on or off. Your AC is either on or off. Okay, so how does it work? Suppose you have too much clouds. Okay, it's an overcast sky. The temperature is low. Okay, remember, cloudy days are cooler than sunny days. High cloud cover means lots of cloud shadows. Okay, just like when you're trying to read a book, you can't. There's no sunlight. Okay, there's not much sunlight that reaches the ocean surface. Remember, that's where all the water is. Okay, so we have now we are reducing the evaporation rate of the water because there's not much sunlight shining on it. Okay, so that reduces the evaporation rate. So now remember we started out with too high a cloud cover. We have reduced evaporation rate. We're making fewer clouds. So the cloud cover now, which was too high, starts to drop. Same thing, okay, and you get equilibrium. Same thing happens in the opposite end. Suppose we have too low, then the surface temperature is too high. Okay, so the reverse process. Lots of sunlight reaches the ocean, you make more clouds, and again, you get equilibrium. So this huge fluctuation of 18 to 55 watts is an asset. That's the power of your furnace or your air conditioning in stabilizing the earth. Okay, so and this happens no matter how much greenhouse CO2 you have in the atmosphere. So Earth, I assert, has a built-in thermostat. Okay. Well, let's look at this feedback system. Well, okay, how's my time doing? Okay. Okay, so, the second task was to measure how strong are these various built-in feedback mechanisms. Given they have these huge fluctuations in power, obviously the Earth is somehow controlling its temperature. We're not experiencing a thermal runaway. And so there are a whole bunch of different efforts done to study feedback mechanism. National Academy had a report, Sherwood et al. I'm thankful to Steve Koonin for calling that paper to my attention. The so-called Ringenberg Castle study and the AR6 IPCC report, Chapter 7, all study cloud feedback mechanisms. I'm going to use it's the only place I ever found any equations for Sherwood et al. And what I'll show is that my mechanism is just so much stronger than anything that they use. Okay, so they have, I won't bore you with all the mathematical details, but there's this, starting with this delta N they call the power imbalance. And they calculate the sensitivity, which is the change of the power imbalance derivative with respect to the change of temperature. So if that number is negative, then we have stabilizing negative feedback. Positive, we have destabilizing feedback. You have a variety of mechanisms working. And each one depends on some other variable. You can use a chain rule from calculus for derivatives. For some reason, Sherwood et al. Said, no, we aren't going to allow you to use cloud cover fraction as one of those intermediate variables. Okay. They also did call, the most strong one they called lambda Planck. That's just the heat radiation variation. They get that wrong too. Planck's law was discovered 20 years after the Stefan Boltzmann law. It's totally misnamed. I know a little bit about quantum mechanics. That's the wrong name. Okay, so here's how you calculate it. So finally, you can get numbers. Remember where I was showing that there was that conservation law I gave earlier for cloud cover fraction albedo. You can use that to calculate one of the terms. So the missing term is how much does the cloud cover change as a function of surface temperature. That you can get just simply how does the vapor pressure of water change? It's about 7% per degree Celsius or degree Kelvin. Okay, so remember I had two choices of cloud albedo, 0.36, which was their silly value, and 0.8, which is what the pictures all show. So depending upon that, you get the anywhere from 5.57 to 13. And so here's the IPCC AR6 diagram. Okay, here is the net. Okay, this is the feedback strength. Okay, down is strong negative stabilizing feedback. Here's what they claim the net is. Here's what they claim clouds were. Put it in my mechanism either for 0.36 albedo or 0.8 albedo. It's a very powerful feedback mechanism. Okay, you'll have time for, okay. Remember, I left out in my diatribes NOAA and extreme weather events. How are we all going to die? What is this pending apocalypse that the IPCC is threatening us with? Well, in 2012, in Physics Today, the directors, two of the not non-scientists, obviously, wrote an article in Physics Today predicting and managing extreme weather events. Earth's climate is warming, destructive weather is growing more prevalent. Coping with the changes will require collaborative science, forward-thinking policy, and an informed public. Okay, i.e. spend trillions of dollars. Okay, here is their first page. The authors were Jane Lubchenco, Undersecretary of Commerce, and Thomas Carl was Director of the labs. Okay, they assert that extreme weather events are already increasing. And they show an index of extreme weather events. They include things like hot spells, cold spells, droughts, floods, landfalling hurricanes. Conveniently, they leave out EF3 plus tornadoes. And as Steve Koonin points out in his book, actually they're dropping. So they had to leave those out, go to a bias for what they didn't want, okay? And they claim that it's obviously increasing. This is a trick I kind of learned from, here is their data they publish. And from this, they're claiming their results. Okay, remember that curve? I'm going to replot it. I replot it twice, not as a bar graph. Nobody does. The scientists actually use bar graphs. Use point graphs. Okay, so I just simply traced their diagram, and I did it twice. And one of them I flipped 180 degrees so that time is no longer increasing to the right, it's increasing to the left. So here are their data points, and they say this shows in the last 3 decades, either this bar or this bar, that extreme weather events are obviously increasing. I assert if you can't tell which way time is going, then you damn well better hadn't spent trillions of dollars on trying to fix it. That's a total crock of crap. Okay, so what are my conclusions? They claim there's a net warming power imbalance. That's how they define global warming. Okay, they're basing it on computer models and on observational data. Both are totally flawed. The modeling predictions totally unreliable, as Steve Coden first pointed out. And so if you can't even account for the past, why should we trust anything you're predicting for the future? Okay? On the observational side, not one of the various observational modalities shows convincingly that we have global warming. The observers have, or whoever had their fingers on the final publication, totally fudged the data dishonestly. And so, remember that 0.6 plus or minus 0.4 that kept popping up? It's a total crock of crap. Okay, so I ask, well, what's really happening? I give you the cloud thermostat mechanism, and I show that it overwhelmingly is the most important process that's occurring in the atmosphere. So my final conclusion is I'm offering you good news. The planet is not in peril. Some people get upset when I say this. How dare you say that the planet is not in peril? I think it's good news. Okay. And finally, the claims are all a hoax. Okay, so what are my recommendations? This is the last slide. We got time for it. Okay, first off, there's no climate crisis. There is, obviously, an energy crisis. We have this huge population that's still growing, and it all needs energy to live. And simply shutting down all important energy production mechanisms, especially fossil fuels and the like, is total insanity. Okay, we're needlessly spending trillions of dollars to limit greenhouse gases in the Earth's atmosphere. This was all done by a stroke of a pen by Lisa Jackson, who was EPA chair under Obama, took power away from Steve Chu, who Department of Energy, put it in her hands in control. She defined it as them as pollutants. They are not pollutants. Simply that one stroke of a pen to erase CO2 and CH4 as pollutants will save you trillions of dollars. And my sponsor here, CO2 Coalition, points out CO2 is actually beneficial, by the way. Okay. All of the government attempts to eliminate carbon should be terminated immediately. You're going to save trillions of dollars by eliminating carbon caps, carbon credits, carbon sequestration, carbon footprints control, zero carbon targets, carbon taxes, and all fossil fuel limits and policies. And they're all the various spin-off industries. Electric vehicles, all electric power, solar, wind power, all could not exist without subsidies. They could not stand on their own. That is a pointless waste of extra money. Okay, so I end with a very famous statement. The old farts in the room will remember Vietnam War and the Apollo program were soaking up a lot of the budget. And so Senator Dirksen said, $1 billion here, $1 billion there. Well, I'm going to update that for inflation. $1 trillion here, $1 trillion there, and pretty soon you're talking about real money. Thank you.